Welcome to Whiteboard Bee Toppers class. Today we are going to learn many interesting things about electricity. Now imagine you have gone home very late one night. Your house will be in darkness. Then what will you do? You will switch on the light. And as soon as you switch on the light, the bulb glows and gives brightness to the room, and you will be able to see everything. Why do you think the bulb glowed when you switched on the light? Is there anything flowing from the switch to the bulb? Is there any connection between the switch and the bulb? Any appliance needs some energy to work. The bulb also must be needing some energy, and that energy must have come from the switch to the bulb like this, and it has made it glow. After a hard day at work, when you want to take bath, what is the next thing you're going to do? You enter the bathroom and then you will switch on the geyser. Once you switch on the geyser, the water will become hot and you will get hot water. What is the geyser doing there? The geyser is heating water and then giving you hot water. How did the geyser heat the water? Geyser needs some energy to heat the water. So from where is the geyser getting the energy? It must be getting energy from through the wire like this, and then it must have heated the water. That is how you are getting hot water. What can this energy be which has heated the water and lighted the bulb? This is nothing but electrical energy. So today, children, we are going to learn about electrical energy. We will now discuss about some appliances which use electrical energy regularly. You can also think about some appliances which use electrical energy and make a note of it. Let us see what they are. What do we have? We have a bulb. Then we have a torch. Now what are both of these? They give us light. A bulb gives us light and a torch also gives us light. And both of them use electrical energy. So what can we infer from this? Electrical energy is being converted into light energy in the case of the bulb and the torch. What is the other appliance using electricity? It is a immersion heater. And again we have an electric iron. Now what do an immersion heater and electric iron give us? They give us heat. So here electrical energy is being converted into heat energy. The next appliance we can see is a ceiling fan, and the other one is a table fan. Why do we need a ceiling fan and a table fan? To give us cool air. Now how do the ceiling fan and the table fan give us cool air? The blades of the fan rotate and then give us cool air. How are the blades rotating? Due to mechanical energy. So we can understand that electrical energy is being converted into mechanical energy in these two cases. Then we have the other appliance, which is the television. All of you are aware of the television, isn't it? It gives us sound, pictures and all that. So here electrical energy is being converted into light energy and sound energy. Then what else do we have? We have a refrigerator. We all know that we use a refrigerator to preserve our food. Why does the food get preserved here? Because the temperature is cool. So the refrigerator uses electrical energy to cool substances. That is, the compressor in the refrigerator works and cools the fridge. So here what is happening, whenever you open the fridge, you can see a bulb glowing also. So electrical energy is being converted into light energy and mechanical energy in the refrigerator. Then the next one is a computer. Now computer is also using electricity, and then the other appliance is the air conditioner. In both these cases also electrical energy is being converted into other forms of energy. What have we understood now? We have understood that electrical energy can be converted into light, heat, mechanical, sound and other forms of energies. But can other forms of energies also be converted to electrical energy? Yes, they can. But you will be learning about that in the later sessions. Let us understand what is electricity now. What is electricity? Electricity is a form of energy. It can be converted into other forms of energy and vice versa. What do you mean by vice versa? The other forms of energy also can be converted into electrical energy. Let us now observe a few interesting phenomena which happen around us in our day-to-day life and try to analyze them. Let us see what they are. Here what do we see? We see a small boy and two balloons are sticking to his cheeks without any support. Now, is it possible? Can any one of you do this? Can you show two balloons just sticking to your cheeks like this? What has the boy done? Something must have happened here to make the balloons stick to the boy's cheeks. Let us see what is the other phenomena we have here. A small girl is coming down a slide. And what is the unusual thing you see here? You can see that her hair is standing out, up like this. It is not being blown by wind or anything. It is just standing out. This is what we have to observe and analyze. Can you do that now? I will now show you how the hair on the girl has stood up. Let us see now. Here we see a boy and he is holding a balloon in his hand. He has a sweater on the sofa behind him. Now, the boy is rubbing the balloon on the sweater and then he has brought it up above his head. And what has happened? The hair has stood up and is touching the balloon. Now, this shows why the girl's hair also stood up, isn't it? The boy has rubbed the balloon on the sweater, and due to friction, something has happened to the balloon, and when he's holding the balloon above his head, his hair has stood up. So from these, we can think that in all these cases, due to rubbing of two objects, something has happened to these objects. They have become charged, and therefore they are attracting small things. I am sure you too must have experienced such a thing. In a dry, hot summer, when you were brushing your hair with a plastic brush or comb, your hair also must have stood up like this boy's hair, isn't it? Let me show you an experiment now, how these things are attracted by a body when it is rubbed. Here I have a plastic tiffin box and I have a silk cloth. Now when I bring it to, these are all thermocoals, colorful thermocoals. When I bring it here, nothing has happened. Now I'm going to rub this with a silk cloth like this. Let us see what will happen. See how the thermocol balls have stuck to the plastic tiffin box. Now, how do you think this attraction has taken place? This is because when I rubbed the plastic box with the silk cloth, both the box and the silk cloth have become charged. Because the box has become charged, it is attracting all these thermocol balls. You've seen here, children, something very interesting, isn't it? Definitely you will also go home and try this today with your tiffin boxes, right? So what has happened up till now, we have seen that whenever two objects are rubbed against each other, then due to friction, they are becoming charged. And due to the charge, they are able to attract very small pieces of either thermocol or pieces of paper and so on. Now, these are all small charges which are developed on bodies. But when it comes to nature, then something will be on a very large scale, on a very large magnitude. Let us see what happens in nature, which is similar to what we have seen in our experiments. What do you see here, children? Have you ever seen this? Did you observe something happening in the sky during a thunderstorm or very heavy rainfall? This is lightning. So how does lightning happen? Clouds are made up of very tiny particles. And during a thunderstorm, these tiny particles get agitated, and due to friction, they become charged. So clouds get charged due to friction of its particles. And when two oppositely charged clouds approach each other, their charges get neutralized. A huge amount of energy is given out in the form of light energy. And then this is what is called lightning. This also happens when charged clouds approach the earth also, and then we experience a bolt of lightning from the sky towards the ground. From all these experiments and this natural phenomena, what have we understood? We have understood that whenever two bodies are rubbed against each other, friction is caused, and due to friction, the bodies are getting charged. But there is no electrical wire here, no switch here, where the electrical energy can come to these bodies. If we compare these charges to the charges which were flowing through the wire in the case of the bulb or the geyser, we notice that there is a difference. Thus, we can say that study of electricity can be of two types: static electricity and current electricity. Static electricity is the study of static charges, and current electricity is the study of charges which are in motion. We can say that the phenomena due to which a suitable combination of two bodies on rubbing get electrified is called electrification. Now, why am I saying two suitable bodies or suitable combination of two bodies? Because all bodies, when they are rubbed against each other, they do not get charged. They do not get electrified. Only a suitable combination of certain substances, when they are rubbed against each other, become charged. We have certain examples. Let us see what they are: glass rod and silk cloth. Whenever a glass rod is rubbed with silk cloth, then the glass rod gets charged and the silk cloth also gets charged. Just now we have seen, we have taken a plastic tiffin box and we have rubbed it with silk cloth and it got charged, isn't it? Similarly, glass rod also, when it is rubbed with silk cloth, will get charged. The other example is ebonite rod and cat skin. Whenever ebonite rod is rubbed with cat skin, then both get charged. Let us now see what happens when certain substances are rubbed against each other. One example, just now we were talking about glass rod and silk cloth. Let us see what happens here. Here we have silk cloth and the glass rod, and this is how they are without any charges before rubbing. But after rubbing, just look at the silk cloth and glass rod. Internally, this is how they will be. We cannot see any charges on any body actually, but when the bodies are charged, they are charged with positive and negative charges. So after rubbing, the silk cloth has negative charges and the glass rod has positive charges. Let us see another example also, that is the ebonite rod and cat skin. Before rubbing, cat skin and ebonite rod are without any charge, that is, they are neutral. But after rubbing, the cat skin is positively charged and the ebonite rod is negatively charged. Now, if you observe both the bodies, you can see that both of them are oppositely charged, and then the quantity of charge is the same in both. The positive charge, the quantity of positive charge as well as the quantity of negative charge is equal among both the bodies after rubbing. But where do these charges come from? They come from matter. What is matter? You, me, the world, this table, this chair, earth, water, air, universe, everything is matter. And what is matter made up of? Matter is made up of very tiny particles called atoms. A neutral atom is made up of an electrically positive central nucleus and negatively charged electrons around it. In the center, you will have a small nucleus like this, which is positively charged, and the electrons will be revolving around the nucleus like this. And the electrons are negatively charged. The quantity of positive and negative charge in a neutral atom is always equal. The quantity, whatever amount of positive charge is there, the same amount of negative charge will be there in an atom. Always these two will be equal. We have discussed about the study of static electricity that there will be no flow of charges at all. Now from where do these charges come whenever two bodies are rubbed against each other? In the case of the bulb and the geyser and all, we have seen some flow of energy was there through the wires. But whereas when we were rubbing these objects, there was no current, flow, nothing. So how do these bodies get charged without any flow? We will try to understand how this electrification happens without any flow of charge. All atoms are electrically neutral. As we discussed just now, the quantity of positive charge and the quantity of negative charge always remains the same. Then when two bodies are rubbed, then the electrons transfer from one body to another body due to friction. Whenever two bodies are come like this and they are rubbed against each other, friction happens. And due to friction, some electrons transfer from one body to the other body. Then the body which loses electrons will become positively charged, and the body which gains electrons becomes negatively charged. Now two bodies are there, both of them are having equal quantity of positive and negative charges. Now when they are rubbed, due to friction, some electrons from one body get transferred to the other body. Then what happens? The body which loses the electrons will have less number of electrons now. Earlier there were equal number of positive and negative charges. Now the negative charges, that is electron, have gone away. Therefore this becomes positively charged. Similarly, the body which is gaining the electrons, then it becomes negatively charged because it is having more number of negative charges. Thus, bodies get charged or electrified on rubbing due to transfer of electrons. So here, transfer of electrons has happened, not flow of electrons. All the examples we have discussed earlier are on the basis of static electricity. We were discussing that when two bodies are rubbed against each other, they get charged. Now let us observe these charged bodies. Now we have a body A which is positively charged, and then we have another body B which is negatively charged. Both are mounted on insulated stands. So this is how a body which is positively charged will be and a body which is negatively charged. Why do we say A is positively charged and B is negatively charged? A is positively charged because electrically it is at a higher level compared to B. B is electrically at a lower level compared to A. So whenever a body is at a electrically higher level, it is said to be positive, and a body which is electrically at a lower level, it is said to be negative. We are observing that the bodies are contained within the body and they are not moving at all. The charges of the body A are within the body A and the charges of the body B are within the body B. So these charges are static, they are not moving, therefore they are said to be static in the bodies. But are charges always static? Can they flow? Can charges flow? Yes, they can flow, provided a path is there between the charges for the charges to flow. When a path is provided, then charges flow from one body to another body. Let us study the flow of electric charges now. We have a positively charged body A, that is this body is electrically at a higher level. Then we have another charged body B, which is electrically at a lower level, and both of them are mounted on insulated stands. Now, if we provide a path to these two bodies, then it will be like this. That is a connecting wire. If we provide a connecting wire which connects the body A to the body B, then the charges will flow from the body A to the body B. Now, how long are these charges going to flow? They will flow until electrically both A and B are equal. And after that, the flow will stop. Now, if we are planning to connect a bulb over here in the wire over here, then how long will the bulb glow? The bulb will glow only until the flow is there. So, as long as the flow is there from A to B, the bulb will glow. And the moment the flow stops, the bulb will stop glowing. Then what will happen? But I want a continuous flow of charges to light a bulb. Then what should I do? To have a continuous flow of charges, I will need a source of electricity which will provide a continuous flow of charges. Like this. This is a cell. And then I have a light and bulb, and then I have connecting wires which are the path. So as long as the path is there, the energy will flow from the battery to the bulb, and then it will make the bulb glow. This will continue to glow until the charge is over, the energy in this cell is over, or if the path is broken anywhere. Until then, the bulb will continue to glow. So whenever I want a continuous supply of electricity, then I will take a cell like this or a source which will provide with electrical energy. How do I know in which direction the current is flowing from the battery to the bulb and back to the battery? So how do I know the direction here? For this, let us observe a waterfall. We have a waterfall here, and then the water is flowing from a mountain to down like this. And then what do we notice here? Whenever water is flowing, it is flowing from a higher level to a lower level. Can this water flow in this direction from bottom to top? We are observing that always water is flowing from a higher level to a lower level. Here also it is flowing from a higher level to a lower level, here also. So everywhere, wherever water is flowing, water is always flowing from a higher level to a lower level. It cannot flow from a lower level to a higher level. Now, can this rule be applied to electrical charges also? Just as the water flows from a higher level to a lower level, electrical charges also flow from an electrically higher level to an electrically lower level. Now, electrically higher level is said to be positive and electrically lower level is said to be negative. Then, the flow of water, we call it as water current. Similarly, the flow of electrical charges also is called electric current. So the flow of water is called water current and the flow of electric charges is called electric current. The study of current electricity is called current electricity. We will be learning about current electricity in our next session, and this session we have learnt about static electricity. What have we learned today, children? We have learned that electricity is a form of energy. We need electricity in our daily life in many appliances. Everywhere, whatever we use requires electrical energy. The electrical energy can be converted into other forms of energy. Similarly, other forms of energy also can be converted into electrical energy. And then we also learned that charges will be accumulated on bodies due to rubbing of certain combination of substances. So certain substances, when they are rubbed against each other, then they will be charged. In static electricity, there will not be a continuous flow of charges. And there are two types of charges, positive charges and negative charges. Current electricity is a study of flow of charges from electrically higher level, that is positive, to electrically lower level, that is negative, when provided by a path. And a path is necessary for current electricity to flow. This is what we have learned today, children. I hope you have understood the lesson and you have understood about static electricity, and I'm sure you are going to go home and try out some of those interesting experiments which we have done. Okay, have a good day, children.